Hi everybody, it's Dr. Morgan, and today we're going to talk about some of the biological mechanisms associated with drug addiction, as well as psychological mechanisms of drug addiction. So let's get started. So let's first start by thinking about what's happening at the synapse. So I've drawn a diagram here that shows the presynaptic neuron in green and the postsynaptic neuron in blue. And you can see there's some green neurotransmitter lying in vesicles that are fusing with that presynaptic membrane, and they're traveling through the synapse, and they're docking on receptors on the postsynaptic membrane. So the green is the neurotransmitter, the receptor is the blue sort of lock and key mechanism. And then the blue arrow indicates that there's an action potential firing in this neuron. And so this is sort of the typical function of a regular neuron. And we're going to use this structure to discuss what tolerance and withdrawal are. So tolerance is when your neurons actually adapt and change in response to the presence of a drug in your body. So let's say you take a drug. Let's say nicotine, for example. And that is displayed in red here. And that nicotine also binds to this same receptor. And so what will happen now is because you're having more receptors bound, you will actually have a stronger action potential, maybe more frequent firing of the action potential. And this is what would create the effect of the drug, whatever feeling that might be. But what's interesting about our bodies is that our bodies recognize this abnormal firing pattern and will actually adapt and change in order to sort of make up for that drug in the body. So what happens? Well, there's two different things that can happen. First of all, the postsynaptic neuron might get rid of some of the receptors. The presynaptic neuron might stop producing as much neurotransmitter. And both of these things are thought to regulate this action potential so that even though there's this drug in the body, the action potential has not become any stronger or more frequent. And this is really what tolerance is. So now you're taking a certain amount of the drug and it's not having that same effect it did in the beginning. So what do you do to get that same effect? Well, you take more of the drug. And then again, you start to get that effect. But what does your body do? The same thing it did in the first place. It gets rid of some of those receptors. It gets rid of some of the neurotransmitter it's making. Until eventually, no matter how much more of the drug you take, you're not going to get any more effect of that drug. And that is what's known as functional tolerance. Now, you might also hear metabolic tolerance, which is a different type of tolerance where your body actually metabolizes the drug differently depending on how long you've been taking it. But at the neurotransmitter level, it really is known as functional tolerance. Now, this process explains withdrawal as well. So these neuronal changes will remain in effect even if you stop taking the drug. And the body will adapt slowly, but not right away. So let's say you decide you're going to stop taking this drug. Well, then what happens is that your body's not making much of that neurotransmitter. All of the receptors have gone away, and now the action potential is not firing. This is going to create the withdrawal symptoms. You are no longer having this neuron firing in the way it was in a normal body. Now, it will take a while for your body to sort of recuperate from this, but it eventually will. And so maybe you'll start having more receptors and a little bit more neurotransmitter, little by little, until that action potential starts firing again. So this is why withdrawal only lasts so long until finally the neuronal mechanisms are sort of brought back into homeostasis. Now, something else we can talk about is known as conditioned drug tolerance. And tolerance is usually thought of as happening at a physiological or neuronal level, but it can also happen psychologically in terms of just your classical condition, Pavlovian conditioning. So tolerance is usually at its maximum when the drug is administered in the same place. And sometimes this is called situational specificity of drug tolerance. So basically, our bodies become used to the fact that a drug is administered in the same place at the same time. And when we go to that same place at the same time, let's say it's a motel or a certain person's bedroom, just being in that position actually creates mechanisms in our body that counteract the effect of the drug, making us psychologically tolerant of it. Now, these are sometimes called conditioned compensatory responses. So our body creates responses that counteract the effect of the drug because it knows that that drug is about to be administered when you're in this specific place. Now, this specific principle is important for overdose because let's say the person who has been used to taking it at the same time in a certain bedroom now moves and starts to take it in the park, and they take the exact same dose. Well, in the bedroom, that dose may have been counteracted by the body's conditioned compensatory responses so much that a very high dose did not have a high effect. But when your body doesn't make those responses to the environment and you're in a whole new environment, the dose that you take might have a much stronger effect and you are more likely to overdose. So there's a lot of documentation that people are more likely to overdose when they administer a drug in a novel or new location from where they usually take the drug. Another psychological phenomenon is known as conditioned place preference. And this is studied a lot in mice models. So when you give mice a contraption where they have two rooms adjoined by a little connecting tunnel, and one room is continually the room where drugs are administered, the rats or the mice come to prefer that room. They come to prefer the room where the drugs have been administered. And this is, again, classical conditioning, but it's classical conditioning for where you want to be, an actual physical location. So this is known as conditioned place preference. Now, this specific psychological paradigm has a lot to do with relapse. So many things cause relapse. We know that just exposure to the drug can cause a relapse. So just one, you've quit cigarettes for a year and then you have one cigarette, might cause a relapse. Stress is also a big factor in relapse. But one of the most important factors in relapse is actually environmental or situational cues. So seeing things or experiencing things that remind you of what that drug felt like. It almost reminds you on a physiological level. And so conditioned place preference has a large role in this. You can imagine something as simple as a bar where you go to smoke and drink, and that sort of becomes a conditioned place that seems very happy or enjoyable to you because of the drugs administered there. Well, if you go into a bar, that may be enough of an environmental cue for you to start using the drug again. And so this is definitely a factor that contributes to relapse. So to summarize, addiction is not just a social phenomenon, things like peer pressure or social lubricants. It's also not just psychological. It's not just due to stress or conditioning. And it's also not just biological. A lot of these things are happening in concert. Our genes and our neurons and peer pressure and conditioning are all working together to influence addiction, overdose, and relapse. So we would call this a biopsychosocial model. So hopefully this helps you understand the psychological and biological principles of addiction a little bit more. And I will talk to you guys again soon. Bye.